And a similar thing happens when you put the clinical thermometer into boiling water. Since the temperature of boiling water would be around 100 degrees, the mercury will raise quite high till 100 degrees Celsius. When you take the thermometer out of the boiling water and place it for a second, you will quickly see that the mercury drops from 100 degrees to 33 or 35 degrees based on your room temperature. But if you remember your clinical thermometer, you will see that it does not happen that way. What happens is you place your clinical thermometer in your mouth below your tongue, you wait for a particular period of time, then you take out the thermometer, then you see the thermometer scale, and you never find that the thermometer level decreases, the level of mercury decreases. It will never happen. Why? Because we have an object called kink within our clinical thermometer. What does this do is, as you can see here, there is a congestion here. This congestion helps or stops the mercury from moving down. So what will happen is, when you find the temperature of your body, you take the thermometer out, the mercury will try to go down, but this kink stops the clinical thermometer to go below this certain point. So this is the difference between a clinical thermometer and a laboratory thermometer. However, these days we have even digital thermometers where there is no need of mercury. So you simply place the thermometer in your mouth, you take out the thermometer, you can read the scale in numbers. So this is a digital thermometer which looks something like this, mentioned in this picture. Now let's try to understand the transfer of heat. Can energy transfer from one form to another? Yes, it can transfer from one form to another. But can it stay in the same form and still transfer? Let us find out what are different ways of heat transfers. So we have three different ways of heat transfer, and we shall discuss them each in detail. So we have the first way of heat transfer, we call it conduction. As you can see in this picture, we have a metal rod, and in this metal rod we have placed certain amounts of wax at different intervals of space. Now we start to hit the rightmost end of this metal here, and slowly we'll observe that the wax will melt at this point, then it will start to melt at this point, then it will start to melt at this point, and so on. So we can say that the heat transfers from a hot end towards a cold end. This process, where heat is transferred from a hotter end to the colder end of an object, is called conduction. So usually wherever you see metals, our utensils that we use in our daily food, the spoons that we eat, all these are made up of metals. Now metals are generally good conductor of heat. So what happens is, if you try to heat one end of a metal, slowly the heat will reach to the colder end. But there are certain substances which do not transfer heat so well as compared to metals. Say for example plastic, for example wood. So if you place one end of the wood to a hotter object, it will not transfer to the colder object. That does not happen. Such substances are called insulators of heat, or they are called the poor conductors of heat. So for example, aluminium, iron, copper would be an example of good conductors, but on the other hand, plastic, wood would be an examples of insulators. The water and air are also poor conductors of heat. We have a second way to transfer heat. We call this as convection. So what happens here is, say for example, you blow a candle as shown in this figure. So if you place your hand just above the flame, you will feel that your hand is getting warmer. But if you place your hands towards the side of the flame, you will not feel that much warm as compared to the hand which was kept on top. So what happens actually is, when you light a candle, it starts to heat the air particles surrounding it. Now we mentioned that the air is not a good conductor of heat. So what happens is, the particles that get heated, they start to rise above in the air. Now since these particles on the flame are gone up, the air particles which were to the surrounding of the candle starts to take place of these particles. So the hotter particles rise above, the colder particles take place of the hotter particles. So as soon as again these new particles get heated, they again start to rise up in the air. Again they are replaced by the new particles surrounding the flame of candle. This process is a continuous process, and the transfer of heat in this manner is called convection. So what happens is, as long as you keep the candle flame on, slowly and gradually the air around the candle will start to get heated. So if you place the candle in an empty room for maybe 10 to 15 hours, you will see that the temperature of the room might have increased a bit, because slowly, very slowly, the heat is transferred from one air particle to the corner of your room. This method is called convection. A common example of convection we all can see, since we are living in a coastal area, we have a beach in our city. What happens is, during daytime, the land gets heated a lot with the amount of sun's heat energy. The sun tries to heat the same thing on an ocean, on the sea, but as we know that water is not a good conductor of heat, so it takes a lot of time for the water to get heated, and meanwhile the land gets heated very quickly. So the air particles on the land region starts to rise above since they are heated. Now this is replaced by the air particles from our sea. So we can say that during a daytime we get a sea breeze, which is a cooler breeze. When this breeze of air comes, we feel this is a humid air. We can feel that. This is called a sea breeze. Now an exactly opposite phenomenon takes place at night. Since water has to take more time to get heated, it also needs more time to get cooled down. But land gets cooled down very quickly. So during the night time, the land gets cooler, but the water in the sea is still hot as compared to land. So since the air particles above the sea are hot, they start to rise, and these are replaced by the air particles from land. Hence during the night time, we have a breeze from land towards sea. So this is a practical example of convection. As you can see in this picture, during daytime the land gets heated, so the air on the land is hot. So this air is replaced by the cool air particles over the sea. But during night time, the land gets cooler very quickly. So we have colder air particles on the land, but hotter air particles towards the sea. So again these hot particles on the sea are replaced by the cool breeze from the land. So that was about the second way of transferring heat. We call it convection. Now we have a third way of heat transfer. We call it radiation. Let's find out about radiation. So when we go outside our home on a summer day, we feel so hot. So how does the heat energy from sun reaches to our surrounding? This is done by the process called radiation. And unlike other ways of heat transfer, radiation does not need any medium to transfer the heat. As seen in the first method, conduction, we need the solid medium to transfer the heat. In terms of second, the convection, we need that the air particles move from cooler end to hotter end. So again we need a medium. But the radiation, with the third process of heat transfer, radiation does not need any kind of medium. So it can travel within vacuum, and as we know that from sun to earth, we have a vacuum between this sun and earth. Still it reaches to earth without any medium. This way of heat transfer is called radiation. Now some practical examples of radiation would be, when you cook your certain food, you might see that the cooker is very hot, or the pan on which you are creating your chapatis would be very hot. But do they stay the same after you finish your lunch or dinner? No, it gets cooler eventually. So how does the heat gets transferred to its surrounding? This happens by the process of radiation. Each object would be able to radiate heat. When there is radiation, what happens is the radiation from a hotter object is released into the surroundings. It can fall onto a specific object. Some might be reflected, some might be refracted, as happens in the case of light. The similar situation happens in case of radiation. So eventually, when you heat a frying pan, and when the frying pan is the work of frying pan is done, you place it anywhere on your platform, and slowly the heat will be radiated to the surroundings. So even human body, we also radiate some kind of heat to our surroundings. We also absorb some heat from our surroundings. Hence it is advised that during summer days we should not go out, because there is radiation from the sun. If we absorb those radiation, we might fall ill, we might have fever. So these are some examples of radiation. Now let's see, for each climate, what type of clothes we should be wearing. So as we know, during summer we try to use cotton cloths, which are very light, which are very reflective. Why reflective? Because as we mentioned, that whenever there is radiation, some part of the radiation would be absorbed by the body, some part of the radiation would be reflected back by the body, and some would be refracted by the body. Now if the body has a more capacity to reflect off the object, we can say that that object will not get hotter as compared to other substances. To give an example, what you can do is, you can take two different vessels, you can paint one vessel with a black color, you can paint another vessel with a white color. Keep a normal water within both the vessels and place them outside your house. After a few minutes or maybe an hour, try to observe the temperature of each of these utensils. You might observe that the temperature of black coated utensil would be higher as compared to white coated utensil. And it is because of the same reason that during winter, when we need more heat, we try to wear dark colored clothes, because it will absorb sun's radiation. But during summer we try to wear light or white colored clothes because it reflects the radiation. We also use woolen clothes during winter. So what happens, what is special about woolen? Well, between the fibers of woolen there is lot of air, and as we know that air and water are poor conductors of heat. So when there is air, it needs lot of time to reach the cold from the outer wear of our sweater or woolen cloth to reach till our body. Hence we have a kind of insulation from the surroundings and our body. Because of this, our woolen clothes keeps us warmer during winter. So that's it for this chapter. Let's see few of our keywords. We have Celsius scale, we know it. What are insulators? Insulators are poor conductor of heat. Sea breeze is a breeze that comes during the daytime from sea to land. What is conduction? Conduction is a way of heat transfer. It usually happens in a metal. It happens from a hotter end to the cooler end. What is land breeze? Is the wind blowing from land towards the sea. Temperature is a measure of heat. Conductor, we know it is a good conductor of heat. Radiation again is a type of heat transfer. and we know thermometers types, and convection again is a type of heat transfer.